Have you ever looked at the silent void of the night sky and wondered what truly happened at the very beginning of everything? How can a cold, silent cloud of dust transform into a blazing giant that rules the heavens for billions of years? In this journey through the cosmos, you will find the answers to the deepest mysteries of our existence and witness the birth of light itself. Before we begin our descent into the cosmic cradle and uncover these ancient secrets, please take a moment to subscribe and like this video to support our search for the truth across the stars. Your support allows us to continue this exploration together. Let us begin our journey into the darkness where everything began. In the beginning, there is only the silence of the great nebulae. These are the stellar nurseries, vast clouds of gas and dust stretching across trillions of miles of empty space. They are the graveyards of old stars and the wombs of new ones. Within these indigo-hued clouds, the temperature is near absolute zero, a cold so profound that motion itself seems to freeze. Yet within this stillness, a hidden dance is taking place. Tiny grains of carbon and silicates, microscopic remnants of ancient explosions, drift aimlessly in the dark. Hydrogen atoms move like ghosts in the void, waiting for a signal that has not yet come. The nebula is a masterpiece of stillness, a painting of deep blues and shadows that has remained unchanged for eons. But gravity is a patient force. It is an invisible hand that begins to tug at the edges of the silence. Somewhere in the heart of the nebula, a ripple occurs. Perhaps it is the distant shockwave of a dying star or a passing gravitational wave, but the balance is broken. The dust begins to stir. Slowly, almost imperceptibly, the particles begin to huddle together. Gravity acts like a magnet in the dark, drawing the scattered gas into a tighter and tighter embrace. This is the start of the collapse. As the cloud shrinks, it begins to spin, much like a dancer pulling in their arms. What was once a shapeless mist becomes a rotating disk of destiny. At the center of this disk, a core begins to form. A protostar is being born in the womb of the deep blue. The pressure builds. The cold of the nebula is replaced by a growing, suffocating heat. The atoms at the center are crushed together with such ferocity that they can no longer resist. This is the moment where physics reaches its limit. The core glows with a dull, infrared light, hidden from the rest of the universe by the thick shroud of dust. It is a secret heart beating in the dark. The more material it consumes, the stronger its gravitational pull becomes. It is a cycle of growth that cannot be stopped. Outside, the nebula remains calm, but inside, a monster of light is preparing to wake up. We are witnessing the transition from nothingness to somethingness. The cradle of dust is no longer a place of rest, but a forge of creation. Soon, the first spark will ignite and the darkness will be banished forever. This is the story of how we began. From dust to cradle, welcome to the silent birth of stars. Deep within the swirling shroud of the nebula, the protostar has become a prison of matter. For millions of years, gravity has been the undisputed master, relentlessly crushing gas and dust into an ever smaller sphere. The core is no longer just hot. It has reached temperatures beyond imagination, climbing towards 10 million degrees Celsius. In this inferno, the very structure of reality begins to change. Atoms, which usually repel each other like magnets turned the wrong way, are forced into such close proximity that they have nowhere left to go. They are crowded together in a chaotic, superheated soup of particles. The pressure is phenomenal, a weight greater than all the oceans of Earth combined, pressing down on every single point. The protostar is teetering on the edge of a profound transformation. It is a cosmic bomb waiting for the ultimate trigger. And then, in a single instant that changes the destiny of this region of space forever, the threshold is crossed. The quantum barriers that keep atomic nuclei apart are shattered by brute force. Two hydrogen protons are smashed together with such violence that they fuse. They do not just collide, they become one. In this forced marriage of particles, something new is created. A helium nucleus is born, and in that act of creation, a tiny fraction of matter is converted into pure energy. This is nuclear fusion. The same power that fuels the cosmos has just been unlocked in the heart of the darkness. It begins as a spark, a single reaction, but it triggers a chain reaction that spreads through the core at blinding speed. The energy released is explosive. For the first time in its long gestation, the star fights back against gravity. The outward pressure of radiation pushes against the crushing inward pull. A tremendous shockwave blasts outward from the core. It tears through the layers of the protostar and slams into the surrounding cocoon of dust and gas that birthed it. The nebula is blown away like smoke in a gale. And there, unveiled from its dusty shroud, a new star shines forth. It is no longer a dark accumulation of gas, but a self-sustaining engine of light. The long night is over. The battle between gravity and pressure has found a temporary truce, a delicate balance that will define the star's existence for eons to come. The ignition is complete. The violent birth is over, and a profound silence returns to the cosmic stage. The new star has entered its longest and most stable phase, known as the main sequence. This is the golden age of equilibrium, a delicate and beautiful truce between two of the most powerful forces in the universe. On one side, gravity is an eternal giant, never resting and always seeking to pull every atom into the center. It wants to crush the star into a single point of darkness. On the other side, the incredible pressure of nuclear fusion pushes outward with the strength of billions of hydrogen bombs. For billions of years, these two titans will be locked in a perfect embrace, neither winning nor losing. This balance is the reason life can exist in the universe. It is a period of immense stability that allows planets to form and civilizations to dream under the steady light of their sun. As we look closer at this burning giant, we see that the surface is far from still. It is a sea of liquid fire, where rivers of plasma as large as Earth rise and fall in a rhythmic dance. Great loops of magnetic energy reach out into the navy blue void, glowing with a ghostly light before snapping back to the surface. These are the flares of a star in its prime. Deep inside the core, the furnace continues its work without interruption. Every second, hundreds of millions of tons of hydrogen are being transformed into helium. This process releases a flood of light that takes thousands of years to travel from the center to the surface. Each photon we see today is a messenger from a distant past, having fought its way through the dense interior of the star before finally escaping into the cold vacuum of space. The star is a lighthouse in the dark, a steady heartbeat that measures the passage of cosmic time. The main sequence is not just a phase. It is a testament to the order that can emerge from chaos. While the rest of the galaxy is filled with drifting dust and violent explosions, the main sequence star remains a constant anchor. It is during this time that the star truly defines itself, its color and its heat determined by the mass it gathered during its birth. Some stars are small and red, burning their fuel so slowly that they will outlast the universe itself. Others are massive and blue, shining with such intensity that they consume their life in a few million years. But for most, including our own sun, this middle age is a time of quiet majesty. It is a slow and deliberate journey across the eons, a story written in light and gravity. As the star drifts through the silent navy void, it creates a bubble of warmth around it, a sanctuary of light in a universe of shadows. This is the stable foundation upon which all of history is built. The star knows nothing of the planets that might huddle around it. It simply exists as a massive engine of creation, oblivious to the tiny specks of rock that orbit its glowing heart. Yet, without this steady flow of energy, the universe would remain a cold and lifeless graveyard. The equilibrium is the ultimate gift of the cosmos. It is the pause between the explosion of birth and the tragedy of death. In this golden age, the star is at peace. It is a monument of light that stands against the encroaching darkness of the void. We are currently living in this age of stability, basking in the glow of a main sequence star that has billions of years left to shine. But even this peace is not eternal. Eventually, the fuel will run low and the balance will shift once more. For now, however, we can rest in the warmth of this cosmic lighthouse, knowing that the golden age continues in the silence of the deep navy sky. The long age of stability is not a permanent state, but a slow consumption of the very essence that keeps the star alive. Deep within the core, the hydrogen fuel that has sustained the furnace for billions of years begins to run low. The perfect balance that once defined the star starts to waver. As the hydrogen is exhausted, the outward pressure of fusion weakens. Gravity, the patient giant that has been waiting for eons, finally finds its opening and begins to crush the core even further. This collapse generates a new and terrifying kind of heat. As the core shrinks and becomes unimaginably dense, the surrounding layers of hydrogen begin to burn with a desperate intensity. This creates a sudden and massive outward surge of energy that the star can no longer contain. The result is a transformation that is as majestic as it is tragic. The star begins to swell, expanding outward into the navy blue void like a balloon of fire. This is the birth of a red giant. The star that was once a stable and concentrated lighthouse becomes a bloated titan of the deep. Its outer surface moves further and further away from the core, cooling as it expands. This cooling shift changes its light from a brilliant white or yellow to a haunting, deep crimson. The star now occupies a volume of space millions of times larger than its original size. Any planets that once orbited in the warmth of the main sequence are now in grave danger. The red giant is an all-consuming god, its fiery atmosphere reaching out to swallow everything in its path. The inner worlds are the first to go, their surfaces melting into oceans of lava before they are finally vaporized by the approaching wall of plasma. It is a silent and slow-motion catastrophe playing out across the stars. The beauty of a red giant lies in its sheer scale and the eerie light it casts across the cosmos. From a distance, it looks like a glowing ember in the fireplace of the universe. But close up, it is a chaotic and violent environment. The surface is no longer a smooth sphere of light, but a turbulent and translucent mist of glowing gas. Great plumes of red material are cast off into space, creating a halo of dust that will one day become the seeds for new worlds. Even as the star dies, it is giving back to the universe the heavy elements it has forged in its heart. The red giant phase is a final act of defiance against the inevitable end. It is a star trying to stay alive by burning everything it has left, expanding its reach in a desperate attempt to find balance once more. But the energy cannot last forever. The fuel is exotic and the process is unstable. In the heart of this crimson giant, the temperature continues to rise until it reaches a point where helium itself begins to fuse into carbon and oxygen. This new fuel source provides a temporary reprieve, but it is a flickering flame compared to the steady burn of the past. The star pulses like a dying heart, expanding and contracting in a rhythmic cycle of agony. The navy void around it is illuminated by these pulses, revealing the ghosts of dead planets and the vast clouds of gas that have already been cast aside. We are watching a giant in its final days, a monument to the power of time and the exhaustion of matter. The red giant is a reminder that even the most powerful entities in the universe must eventually change and fade. It is a transition from the order of the main sequence to the chaos of the end. The silence of the deep space is now filled with the red glow of a dying king, preparing for the final collapse that will change the galaxy forever. For millions of years, the massive red giant has been fighting a losing battle against its own gravity, furiously fusing heavier and heavier elements in a desperate attempt to maintain the balance. Carbon turns to neon, neon to oxygen, and oxygen to silicon in a nesting doll of fiery shells around the core. But this cosmic alchemy has a fatal limit. Deep in the heart of the star, the silicon fuses into iron, and the game is over. Iron is the ultimate ash of nuclear burning. It is the most stable element in the universe, and fusing it does not release energy, it consumes it. The moment iron begins to accumulate in the core, the star's fate is sealed. The energy production that held up the massive weight of the star's outer layers suddenly stops. The balance that existed for eons is broken in a single instant. Gravity, having waited patiently in the shadows, now asserts its absolute dominance with terrifying speed. In less than a second, a structure larger than our entire solar system collapses in on itself. The outer layers of the star fall inward at speeds approaching a quarter of the speed of light. It is the most catastrophic structural failure in the universe. The core is crushed down from a sphere the size of Earth to a dense ball only a few miles across. The atoms are smashed together so tightly that protons and electrons merge to form neutrons. The core becomes an object of unimaginable density, a neutron star, which is so rigid that it cannot be compressed any further. The infalling matter, billions of trillions of tons of superheated gas, slams into this immovable wall of neutrons and bounces off with ferocious violence. A shockwave of unbelievable power is generated, a tsunami of pure energy that blasts outward from the center, tearing through the collapsing star. This is the supernova. In the brief moments of the explosion, the star shines with the brilliance of 100 billion normal suns, temporarily outshining the entire galaxy in which it resides. It is a flash that can be seen across the deepest reaches of the cosmos. But this event is not just an act of ultimate destruction. It is also the greatest act of creation since the Big Bang itself. In the intense heat and pressure of the shockwave, a new kind of alchemy takes place. The star becomes a cosmic forge, creating elements heavier than iron. Gold, silver, platinum, and uranium are birthed in the fiery chaos of the explosion. These precious materials, along with the carbon and oxygen formed earlier in the star's life, are blasted out into the surrounding navy blue void at incredible speeds. The death of the giant becomes the seed for future generations of stars and planets. The dust clouds that will one day form new worlds are enriched with the debris of this cataclysm. Every atom of gold on Earth, every bit of calcium in your bones, was forged in the heart of a dying star and scattered across the universe by a supernova. We are, quite literally, made of stardust created in the universe's most violent moments. The echoes of the supernova have faded into the navy blue distance, but what remains at the heart of the explosion is perhaps the most terrifying and fascinating object in the entire cosmos. When the massive star collapsed, gravity did not just crush the matter. It fundamentally altered the nature of reality itself. The result is a neutron star, a tiny ball of pure density that defies everything we understand about the physical world. Imagine an object only 12 miles across, small enough to fit within the boundaries of a human city, yet possessing a mass greater than our entire sun. This is the ultimate remnant, a graveyard of atoms where space and time are bent to their absolute limits. In this indigo-colored void, the neutron star stands as a monument to the sheer power of gravitational collapse. If you were to take a single teaspoon of the material from this star, It would weigh billions of tons, more than all the mountains on Earth combined. This is because the atoms have been crushed so tightly that there is no empty space left within them. The electrons and protons have been forced together to create a solid sea of neutrons. It is a state of matter so exotic that it exists nowhere else in the universe, except in these silent, spinning tombs. The surface of a neutron star is incredibly smooth, covered in a crust of iron atoms that is stronger than any diamond. Gravity here is so intense that the tallest mountains are only a few millimeters high. To stand on such a surface is impossible, for the weight of your own body would flatten you into a layer of atoms thinner than paper in a fraction of a second. As we watch this tiny giant in the darkness, we see that it is spinning with incredible speed. Some neutron stars rotate hundreds of times every single second, turning so fast that they appear as a blur of energy. These are the pulsars, the lighthouses of the deep universe. From their magnetic poles, they emit beams of intense radiation that sweep across the cosmos like searchlights in the night. When these beams cross our path on Earth, we hear them as a steady, rhythmic heartbeat coming from the stars. It is a sound that was once mistaken for signals from alien civilizations, but we now know it is the song of a dying star that refuses to go quietly into the night. The magnetic field surrounding this object is trillions of times stronger than that of the Earth, a force so powerful that it could rip the atoms of your body apart from thousands of miles away. The environment around a neutron star is a chaotic ballet of energy and light. The intense gravity pulls in any nearby gas or dust, accelerating it to nearly the speed of light before it slams into the surface. This process releases massive bursts of X-rays and gamma radiation that illuminate the surrounding Navy nebula. The blue clouds of gas are the ghosts of the star's former self, now trapped in the eternal grip of the remnant. In this section of our journey, we witness the true meaning of density and the ultimate fate of mass. The neutron star is not just a dead core, it is a living engine of physics, pushing the boundaries of what is possible in our universe. It is a silent sentinel in the dark, a reminder that even when a giant dies, its spirit remains as a concentrated force of nature that will last for billions of years in the cold silence of the stars. In the vast and silent tapestry of the navy blue cosmos, there exists a phenomenon so absolute and so terrifying that it challenges the very foundations of everything we believe to be true about reality. We have seen the birth of stars and the violent majesty of supernovas, but now we reach the final frontier of gravity's insatiable hunger. When a star of truly colossal mass reaches the end of its life, not even the formation of a neutron star can halt the total collapse. The gravity becomes so overwhelming that it crushes the core past any known physical limit. Matter is compressed into a region of space so small that the density becomes infinite. This is the birth of a black hole, a dark tear in the fabric of space-time, where the laws of physics as we know them simply cease to exist. It is a place where light itself is imprisoned, and where the concept of time loses all meaning. In this deep indigo void, we are looking into the ultimate abyss. Imagine a sphere of absolute darkness floating against the background of distant galaxies. This is the event horizon, the invisible boundary that marks the point of no return. Once an object crosses this threshold, no force in the entire universe, no matter how powerful, can escape the pull. Not even light, the fastest thing in existence, can find its way back to the outside world. Because light cannot escape, we can never see the black hole itself. We can only see the chaos it creates in its surroundings. Around the event horizon, a massive disk of superheated gas and dust swirls at nearly the speed of light. This accretion disk glows with a haunting blue and violet radiance, a final scream of matter before it is consumed by the darkness. As the gas is pulled in, it is compressed and heated to billions of degrees, emitting intense X-rays that cut through the silent void like cosmic beacons. The space around the black hole is warped and twisted, acting like a giant lens that bends the light of distant stars into strange and beautiful halos. As we drift closer to this gravitational monster, the very nature of time begins to change in ways that defy human logic. According to the theories of relativity, gravity is not just a force but a warping of space and time. Near a black hole, this warping is so extreme that time begins to slow down significantly. If you were to watch an astronaut falling toward the event horizon from a safe distance, you would see them moving slower and slower as they approached the boundary. To your eyes, they would appear to freeze at the edge of the darkness, their image fading into a deep red glow until they vanished forever. But for the astronaut, time would feel perfectly normal as they were swept into the void. This paradox reveals the terrifying truth of the cosmos. Time is not a constant, but a flexible thread that can be stretched and broken by the weight of the stars. Beyond the event horizon lies the singularity, a point of zero volume and infinite density. Here, the math of our greatest scientists fails. The dimensions of length, width, and height disappear. We do not know what happens at the heart of a black hole, for it is a secret that the universe refuses to share with the light. The black hole is not just a harvester of matter, but a silent architect of the galaxies. At the center of almost every large galaxy, including our own Milky Way, sits a supermassive black hole millions of times heavier than the Sun. These giants act as anchors, their immense gravity holding the billions of stars in their orbits and shaping the spiral arms of the galaxy. They are the engines of cosmic evolution, occasionally waking up to consume entire star systems in a display of raw power. When they feed, they launch massive jets of energy and particles from their poles, stretching across thousands of light years into the navy blue expanse. These jets can trigger the birth of new stars in distant nebulae or destroy entire planetary systems. The black hole is a paradox of destruction and creation, a dark heart that pumps the lifeblood of gravity through the universe. It is the ultimate manifestation of the power of the void. As we contemplate these dark giants, we realize how small and fragile our own existence truly is. We are living in a universe that contains regions where space and time have been discarded, where the light of the stars is swallowed by an eternal night. The black hole remains the greatest mystery of the deep, a reminder that there are places in the cosmos where we can never go, and secrets that will remain hidden in the silence forever. Beyond the boundary of the event horizon, past the point where the last rays of light are swallowed by the eternal shadow, we enter the most mysterious and mathematically impossible region of the entire cosmos. We are moving toward the singularity, the absolute heart of the black hole where the known universe simply stops being. Imagine a place where the weight of millions of suns is crushed into a point with no physical size at all, a place of zero volume and infinite density. This is a concept that challenges the very sanity of our greatest scientists and pushes the boundaries of human imagination to their breaking point. In this deep navy blue void of the inner horizon, the fabric of space and time is not just bent, it is torn apart beyond any hope of repair. We are witnessing the ultimate victory of gravity over matter and light. It is a silent, crushing heart of darkness that sits at the center of the cosmic stage. As we descend deeper into this indigo abyss, the classical laws of physics begin to unravel like a fraying thread. According to Einstein's general relativity, space and time are linked in a four-dimensional fabric. But near the singularity, the curvature of this fabric becomes infinite. It is like a needle pressing down on a sheet of silk with the weight of the entire world behind it, eventually punching a hole through the very foundation of existence. Here, the concepts of up and down, or before and after, lose all their meaning. Time itself becomes a spatial dimension, pulling everything toward the center with a force that cannot be resisted. You cannot move away from the singularity for the same reason you cannot move away from the future. It is a destination that is written into the geometry of the universe. The silence here is absolute, for no vibration and no signal can ever hope to escape the crushing embrace of this mathematical ghost. What truly lies at the exact center of this darkness? Some theorists suggest that the singularity is not just a point of destruction, but a gateway to something beyond our understanding. Perhaps it is a bridge to another universe, a white hole that spews matter out into a different dimension of time and space. Or perhaps it is a cosmic eraser that destroys every piece of information that falls into its grasp. This is the great information paradox that keeps physicists awake at night. If the universe is a book where every atom is a word, does the black hole burn the pages or simply hide them in a place where they can never be read again? The singularity is the ultimate guardian of the universe's secrets. It is a place where the macroscopic world of gravity meets the microscopic world of quantum mechanics, and where both theories fail to provide an answer. It is the great unknown, a silent monument to the limits of human knowledge. If you were to approach the singularity, you would experience the most extreme manifestation of tidal forces in the universe. This is a process often called spaghettification, where the gravity at your feet is so much stronger than the gravity at your head that your very atoms are stretched into a long, thin line of light. But in our silent documentary journey, we look past the physical destruction and see the philosophical weight of this place. The singularity represents the end of the story for everything that enters its domain. It is the final period at the end of a cosmic sentence. Yet, at the same time, it is the same state of being that the entire universe occupied at the moment of the Big Bang. We are looking at the beginning and the end of time simultaneously. The heart of darkness is also the cradle of all that is. In this navy blue silence, the singularity remains the ultimate enigma, a dark mirror reflecting the mysteries of our own origin and the inevitable fate of the stars. It is the silent heartbeat of the galaxy, a point of infinite power that governs the dance of billions of suns while remaining forever hidden from our sight. In the year 1977, humanity launched two small messengers into the great navy blue ocean of the cosmos. These were the Voyager probes, fragile machines of metal and glass sent to explore the giants of our solar system and then drift forever into the silent darkness beyond. They were our first true attempt to reach across the void and say, "We were here." As they left the warmth of the Earth behind, they carried with them the collective curiosity of a species that had only recently learned to leave its own atmosphere. For decades, these lonely travelers danced with the rings of Saturn and braved the massive storms of Jupiter, sending back images that forever changed our understanding of the universe. But their true mission was always something far more profound and haunting than simple planetary science. They were destined to become the first human objects to enter the interstellar void, leaving the protective bubble of our sun behind forever. As Voyager 1 reached the edge of our solar system, it turned its cameras back one final time to capture a photograph that would haunt humanity for generations. It was the image of a pale blue dot, a tiny speck of dust suspended in a sunbeam. In that single frame, everything we have ever known, every war fought, every love shared, and every empire built was reduced to a microscopic pixel against the overwhelming navy blue of the deep space. It was a reminder of our terrifying insignificance and the fragile beauty of the only home we have ever had. After that moment, the cameras were turned off to save power, and the Voyagers began their long, silent journey into the absolute dark. They are now drifting in the space between the stars, where the light of our sun is no more than a bright pinprick in a sea of shadow. There is no air here, no sound, and no turning back. They are the ultimate exiles, wandering in a region of space where no human eye will ever follow. Attached to the side of each craft is a golden record, a message in a bottle cast into the cosmic sea. It contains the sounds of our world, the laughter of children, the songs of birds, and the music of our greatest composers. It is a testament to our existence, intended to be found by civilizations that may not even exist yet, or that may never find it at all. The record is a prayer offered to the silence, a hope that somewhere in the vastness of the deep blue, we are not truly alone. But as the years pass, the plutonium hearts of the Voyagers are slowly growing cold. Every day, the signal that reaches Earth becomes a little bit fainter, a dying whisper from a distance that the human mind cannot truly comprehend. Soon, the last of their instruments will fall silent, and they will become ghost ships, drifting for millions of years through the galaxy without a destination. They will outlast the pyramids, they will outlast the oceans, and they will outlast the very species that created them. We are watching the slow and graceful disappearance of our own history into the infinite. Voyager is not just a machine. It is a part of us that has already left the nest. It represents our courage to face the unknown and our desire to be remembered in a universe that is mostly cold and empty. As they move deeper into the interstellar navy void, they carry our dreams into a future where the Earth itself may no longer exist. They are the silent witnesses of our ambition, drifting past the ghosts of stars and the shadows of undiscovered worlds. In the silence of the deep, the Voyagers remain our final goodbye, a beautiful and tragic echo of a civilization that dared to look at the stars and wonder what lay beyond. They are the eternal wanderers, and their journey is just beginning in the endless night of the cosmos. We may never hear from them again, but we know they are there, carrying the soul of humanity into the heart of the great mystery. Attached securely to the side of the fragile robotic explorer, gleaming against the absolute blackness of interstellar space, is an object that is both the most arrogant and the most humble thing humanity has ever created. It is a 12-inch disc of gold-plated copper, a phonograph record containing a carefully curated selection of sounds and images intended to represent our entire planet. This is the Golden Record, a time capsule designed to survive for billions of years in the harsh environment of the cosmic void. It is a message in a bottle cast into the largest ocean imaginable, with the faint hope that perhaps, someday, eons from now, it might wash up on the shores of an alien civilization. The chances of it being found are infinitesimally small, almost zero, yet the act of creating it speaks volumes about the human condition. We know we are small, we know our time is limited, but we possess an unstoppable desire to reach out and connect, even if only with the silent future. The contents of the record are a vibrant symphony of Earth's existence, a snapshot of who we were in the late 20th century. It begins with the sounds of our planet before humanity even existed. The rumble of earthquakes, the roar of volcanoes, the crashing of ocean waves upon an ancient shore, and the whistling of the wind through primordial forests. Then come the sounds of life, the songs of humpback whales echoing in the deep, the chirping of crickets in the night, the howling of wolves, and the complex calls of chimpanzees. It is a testament to the rich biodiversity of the world that birthed us. And finally, the voices of humanity itself. Greetings in 55 different languages, from ancient Sumerian to modern English, all saying some variation of peace and hello to unseen ears. There is the laughter of a child, the sound of a kiss, footprints in the snow, and the rhythm of a heartbeat. It is an attempt to condense the entirety of the human experience into groove and analog signal. Music is perhaps the most universal language we possess, and the record carries a 90-minute concert meant to convey human emotion across the species barrier. It includes the mathematical precision of Bach's Brandenburg concertos, the soaring majesty of Mozart's Queen of the Night aria, the raw energy of Chuck Berry's rock and roll, and the haunting melodies of indigenous folk music from around the globe. It is a playlist for the cosmos, a demonstration of our capacity for creativity, joy, and sorrow. Encoded alongside the sounds are 116 analog images, pictures that show our anatomy, our cities, our landscapes, and our scientific understanding. There are diagrams of DNA structure, photographs of humans eating and drinking, images of the Great Wall of China, and views of Earth from orbit. It is a desperate attempt to show not just that we existed, but what it felt like to be alive on this particular blue planet. But how would an alien intelligence know how to play this ancient technology or where it came from? On the aluminum cover of the record, etched with scientific precision, are the instructions. There are diagrams defining the speed at which the record should be played, using the fundamental transition time of the hydrogen atom as a universal clock. Most hauntingly, there is a map. It is a pulsar map, locating our sun relative to 14 rapidly spinning neutron stars in our galaxy. By measuring the precise pulse rates of these stars, an advanced civilization could calculate not only where the Voyager probe launched from, but also when it was launched. It is a cosmic address and a timestamp that will remain valid for hundreds of millions of years. The golden record is more than just data. It is a gesture of profound hope and terrifying loneliness. As Voyager sails further into the eternal silence, the gold will not tarnish and the grooves will not fade. It will likely outlive Earth itself, becoming the final, silent monument to a species that once dared to look up and dream of not being alone. As our lonely Voyager continues its relentless journey away from the warmth of the inner planets, it crosses an invisible yet profound boundary in the dark. We are now passing the orbit of Pluto, the frozen gatekeeper of the outer reaches. At this staggering distance from the Sun, the light of our star has lost its life-giving heat and has become nothing more than a piercingly bright needle of white light in an ocean of indigo shadow. The Sun is now billions of miles behind us, and its gravitational grip, though still present, begins to feel like a fading memory. Pluto itself is a world of silent majesty, a landscape of frozen nitrogen mountains and vast plains of crystalline ice that have never known the touch of a warm breeze. It is a place of absolute stillness where the shadows are long and the sky is a deep, permanent navy blue. To pass this point is to leave the familiar neighborhood of the major planets and enter the mysterious realm of the Kuiper Belt. This is the graveyard of the solar system, a vast ring of icy debris and ancient rocks that were left over from the violent birth of the Sun. Trillions of objects, from tiny pebbles of ice to massive dwarf planets, drift here in the eternal cold, waiting in the darkness like ghosts of a forgotten era. The transition into the interstellar void is not a sudden event, but a slow and haunting descent into the true deep. As Voyager moves further into this icy frontier, it enters a region of space where the density of matter is lower than anything found near Earth. The vacuum here is nearly perfect, yet it is filled with a thin mist of charged particles known as the solar wind. This wind is the breath of our Sun, a stream of energy that creates a protective bubble around our planetary system. But even this breath is beginning to falter. We are approaching the edge of the heliosphere, the great boundary where the Sun's influence finally meets the pressure of the interstellar medium. Outside this bubble lies the raw, unshielded galaxy. The environment around the spacecraft is becoming increasingly alien. The magnetic fields of the sun are stretching and twisting, struggling to maintain their shape against the encroaching cold of the deep space. Voyager is now a tiny island of technology floating in a sea of nothingness, its sensors reaching out to detect the first hints of the interstellar wind that blows between the stars. The loneliness of this region is difficult for the human mind to comprehend. If you were to look out from the hull of the spacecraft, you would see no familiar landmarks. There are no moons to reflect the light and no clouds to hide the stars. The silence is so profound that it feels like a physical weight against the metal skin of the probe. Every hour that passes takes Voyager another 38,000 miles further into the abyss, yet the view remains unchanged for years at a time. We are in the no-man's land of the cosmos, a place that belongs neither to the sun nor to the stars beyond. The energy levels within the spacecraft are carefully managed, as the distant cold seeks to drain the life from its nuclear heart. Yet, the machines continue to hum in the dark, recording the transition from the familiar to the unknown. This is the point where our maps end and the true exploration begins. We are witnessing the final departure from the solar family, a moment of profound significance that marks our first true step into the galaxy at large. The navy blue void ahead is vast and empty, a canvas of darkness that will not see another sun for tens of thousands of years. By crossing the orbit of Pluto, we have committed ourselves to the eternal night. There is no path that leads back to the light of the inner worlds. The spacecraft is now a messenger of the deep, carrying the echoes of Earth into a realm where time itself seems to move differently. The Kuiper Belt objects that pass by in the distance are like silent sentinels, watching our departure with indifferent eyes. They are the remnants of a time before life existed, frozen witnesses to the long history of our system. As we move past them, we are moving past the very limits of our ancestors' imagination. The interstellar void is not just a physical space, it is a state of being. It is the ultimate test of our technology and our spirit. Ahead lies the Heliopause, the final wall of fire and shadow that separates us from the rest of the universe. Voyager is ready. It has spent decades preparing for this moment, and as it glides through the indigo silence, it does so with a grace that only the stars can understand. The journey into the void is no longer a dream. It is a reality unfolding in the silent navy sky. After 35 years of travel through the dark cold of the outer solar system, Voyager has reached the final frontier. We have arrived at the Heliopause, the ultimate boundary where the domain of the sun ends and the true galaxy begins. This is not a simple line in space, but a vast and turbulent region where two immense forces collide in a silent, cosmic struggle. On one side is the solar wind, a stream of charged particles that has been blowing outward from our sun for billions of years, creating a protective bubble known as the heliosphere. On the other side is the interstellar medium, a chaotic sea of gas and dust that fills the space between the stars. For decades, Voyager has been sailing within the calm waters of the sun's magnetic influence, but now it has reached the shore. The transition is violent and unpredictable. The sensors on board the spacecraft begin to register a dramatic shift in the environment. The constant stream of solar particles, which has been a steady companion since leaving Earth, suddenly drops to near zero. At the same time, the intensity of galactic cosmic rays, high-energy radiation from distant supernovae and black holes, spikes sharply. These are the signals that we have crossed the threshold. The magnetic field around the probe twists and distorts, no longer aligned with the sun, but indicating the presence of a new, alien magnetic environment. This is the shockwave where the sun's wind slams into the interstellar matter, creating a turbulent wall of plasma that glows with a faint, ghostly light in the deep navy void. It is a celestial barrier of immense proportions, stretching for billions of miles in all directions. Crossing the Heliopause is like sailing a small boat out of a protected harbor and into the open ocean during a storm. The plasma here is dense and chaotic, heated by the friction of the collision to tens of thousands of degrees. Yet, because the gas is so thin, this heat does not feel like warmth, but rather manifests as a chaotic magnetic storm. Voyager is buffeted by these unseen forces, its delicate antennas trembling as they slice through the turbulent boundary. It is a moment of profound risk and triumph. The little spacecraft, built by human hands, is now the only object made by man to be truly outside our solar system. It has become an interstellar traveler. The sun, which has been its guide and energy source for so long, is now just another bright star in the distance, indistinguishable from the thousands of others that dot the navy blue canopy. The silence here is deeper than anything we have experienced before. The comforting hum of the sun's magnetic field is gone, replaced by the cold, indifferent silence of the galaxy. We are now sailing on the winds of stars we will never see. The interstellar medium is a vast and ancient ocean, filled with the dust of dead worlds and the seeds of new ones. Voyager's mission has entered a new phase. It is no longer exploring the planets of our system, but is now sampling the very fabric of the Milky Way. Every bit of data it sends back is a revelation, a first glimpse into the true nature of the universe beyond our doorstep. The crossing of the Heliopause is a monumental achievement, a testament to our curiosity and our technological prowess. It is the moment humanity truly left home and stepped into the boundless expanse of the cosmos. As Voyager drifts further into the interstellar night, it leaves behind the only bubble of safety we have ever known, becoming a permanent resident of the deep, navy blue unknown. Deep within the metallic hull of the lonely explorer, far from the reaches of any sun or star, a silent and invisible process is slowly coming to an end. This is the story of Voyager's heart, its radioisotope thermoelectric generators, the small nuclear batteries that have kept the machine breathing for nearly half a century in the absolute zero of the cosmic void. When these probes left Earth in 1977, their plutonium-238 cores were glowing with a fierce and potent heat, providing enough electricity to power all their cameras, computers, and scientific sensors. But plutonium is a substance of limited time. With every passing second, the radioactive atoms decay, and the warmth they provide begins to fade away like the embers of a dying campfire in a vast and frozen forest. Each year, the spacecraft loses about 4 watts of power, a tiny amount that would go unnoticed in a human home. But in the deep navy blue of interstellar space, it is a matter of life and death. The engineers back on Earth, the silent guardians of this distant mission, are forced to make agonizing decisions to keep the heartbeat of the probe alive. One by one, they have sent signals across the billions of miles to turn off the heaters that protect the scientific instruments from the biting cold. First, the cameras were silenced, their eyes closed forever to save the precious energy for the sensors that measure the interstellar wind. Then, the heaters for the cosmic ray instruments were cut, allowing the metal to drop to temperatures that would shatter any terrestrial machine. Yet, against all odds, the Voyager persists. It is a testament to the incredible craftsmanship of a bygone era, a machine that refuses to surrender to the encroaching darkness. The interior of the probe is now as cold as the void itself, its components shivering in the deep indigo silence, yet its central processor continues to pulse with a faint and rhythmic hum. As the power levels continue to drop, the signal that Voyager sends back to Earth becomes a fragile whisper. To hear this voice, humanity must use its largest radio telescopes, pointing them toward a specific coordinate in the navy blue sky and listening with absolute focus. The data takes over 21 hours to travel at the speed of light to reach our ears, a message from a ghost that is still walking in the dark. We are watching the slow and graceful death of a machine that has become more than just metal and wires. To us, Voyager's fading battery represents the limit of our own reach and the inevitable exhaustion of all things. Even the most powerful engines of creation eventually run dry. In the silence of the deep, we are witnessing the final stages of a journey that will soon become a silent drift. The probe is slowly losing its ability to talk to its creators, and when the last watt of power is consumed, it will fall into a permanent sleep. The loneliness of this fading heartbeat is profound. Voyager is like a lighthouse whose lamp is slowly dimming, its beam no longer strong enough to cut through the heavy shadows of the galaxy. But even when the electricity is gone, the probe will continue to exist as a silent monument to our ambition. Its heart may stop beating, but its body will travel through the stars for millions of years, carrying the golden record and the memory of the blue planet into the eternal future. The fading battery is not a failure, but a completion. It is the natural end of a heroic era. As we listen to the last rhythmic pulses from the deep Navy void, we feel a sense of reverence for the little machine that could. It has given us everything it had to give, and now it prepares to join the silent stars as a quiet and frozen messenger of humanity. The heartbeat may be fading, but the legacy of the Voyager is written in the stars forever. The final pulse has left the high-gain antenna and traveled across the staggering distance toward a world that may no longer remember the names of the people who built this machine. The electronic hum that once defined the life of the probe has dissolved into the absolute silence of the interstellar medium. Voyager is no longer a tool of active science, but a ghost ship of humanity, a silent silver needle threading its way through the infinite tapestry of the navy blue void. In this state of eternal drift, time ceases to be measured in hours or years, but in the vast and cold stretches of the parsec. The sun is now just one of many thousands of bright dots in the indigo sky, its warmth a forgotten dream in a region of space where the temperature is barely above the absolute zero of existence. There is no wind to stir its gold-plated record, and no air to carry the sounds of the children's laughter etched into its grooves. It is a monument of stillness, moving at tens of thousands of miles per hour, through a vacuum so perfect that the machine is preserved as if frozen in a block of invisible ice. Ahead lies the Oort cloud, the massive shell of icy remnants that surrounds our solar system like a field of sleeping ghosts. It will take Voyager another 300 years just to reach the inner edge of this frozen frontier, and 30,000 years to finally emerge on the other side. Here, the spacecraft will drift past ancient comets that have never seen the light of a planet, silent observers of the long history of the stars. In the deep navy silence of this region, Voyager is the only thing that changes. It is a tiny island of complex order in a sea of primordial chaos. The metal of its hull remains cold and dark, reflecting only the distant and indifferent glint of the stars. We are witnessing the birth of a cosmic relic. Long after the cities of Earth have crumbled to dust and the oceans have changed their shores, this machine will still be flying. It is protected by the very nothingness that surrounds it, safe from the erosion of wind and water, guarded by the eternal vacuum of the deep. As the eons pass, Voyager will begin its slow approach toward other stars. In about 40,000 years, it will pass within 1.6 light-years of the star Gliese 445 in the constellation of Camelopardalis. It will be a silent encounter in the dark, two travelers passing in the night without a word. The star's gravity will gently tug at the probe, slightly altering its course, but never stopping its relentless journey into the heart of the Milky Way. By then, the plutonium heart will be cold as stone, and the electronics will be nothing more than brittle patterns of silicon and gold. Yet, the golden record will remain intact, its message of peace and its map of the sun still waiting for a hand that may never come. Voyager is our most successful attempt at immortality. It is a part of us that has transcended the limits of our biology and our planet, a piece of human thought and ambition that will outlast the very sun that birthed us. In the silence of the stars, we realize that Voyager's journey is no longer about exploration, but about presence. It is proof that we were once here, that we once loved, and that we once looked at the sky with a curiosity that could not be contained by the atmosphere. The deep navy void is no longer just an empty space because Voyager is in it. It has become a cathedral of human memory, a silent messenger carrying the soul of the 20th century into a future so distant it is beyond human comprehension. Even if humanity vanishes from the universe, the record of our existence will continue to drift through the indigo shadows, a beautiful and tragic echo of a civilization that dared to touch the stars. Voyager is the ultimate wanderer, a lonely soul finding peace in the infinite dark, moving forever toward a destination that has no name and no end. It is the final testament of our species, a silent song of iron and gold echoing in the eternal silence of the deep navy sky. As the lonely silhouettes of the Voyager probes fade into the eternal shadows of the interstellar medium, we turn our collective gaze back toward the stars with a new and burning question that has haunted the human spirit since the dawn of time. We have explored the immediate neighborhood of our own sun, but what lies beyond the cold and silent borders of our solar family? For centuries, we looked at the night sky and saw only distant points of light, tiny diamonds set against the navy blue velvet of the void. We wondered if those lights were accompanied by worlds of their own, planets where mountains might rise under different suns, and where oceans might crash against alien shores. This is the frontier of the exoplanet search, the great hunt for new Earths that has transformed our understanding of the universe in a single generation. We are no longer limited to the 8 planets of our system. We have discovered that the galaxy is not just a collection of stars, but a vast garden of worlds, each one a unique and mysterious jewel floating in the indigo dark. The challenge of finding these distant worlds is a testament to human ingenuity and the absolute limits of our technology. A planet does not shine with its own light. It is a tiny speck of rock or gas hidden in the overwhelming glare of its parent star. Finding an exoplanet is like trying to see a tiny firefly hovering next to a massive searchlight from thousands of miles away. Yet, we have learned to see the invisible. Using the transit method, we watch for the moment a planet passes in front of its sun, causing a minuscule drop in the star's brightness. This tiny flicker, no more than a shadow in the dark, tells us that a world exists. We measure its size, its orbit, and the length of its year. Through the radial velocity method, we observe the star itself as it wobbles ever so slightly, pulled by the gravitational tug of its hidden companions. These rhythmic movements are the heartbeats of distant solar systems, signals from across the light years that tell us we are living in a crowded universe. Among the thousands of worlds we have discovered, we search for the most precious prize of all, the Goldilocks zone. This is the narrow region around a star where the temperature is just right, not too hot to boil the oceans and not too cold to freeze them solid. It is the sanctuary where liquid water might exist, the essential cradle for life as we know it. When we find a planet in this zone, we look at it with a mixture of awe and longing. We see super-Earths, massive rocky worlds with crushing gravity, and sub-Neptunes wrapped in thick blankets of mysterious gas. We see worlds where it rains glass or molten iron, and planets that are forever locked in a state of eternal day and eternal night. But somewhere among these exotic landscapes, we hope to find a mirror of our own home, a world with blue skies and liquid water, a place where the chemistry of life might have found a way to begin its long and beautiful dance under the light of a different sun. The search for new Earths is more than just a scientific endeavor. It is an emotional and philosophical journey into the deep Navy unknown. Every discovery reminds us of the incredible diversity of the cosmos and the unique circumstances that allowed our own world to flourish. We are now beginning to peer into the atmospheres of these distant worlds, looking for the chemical signatures of life. Oxygen, methane, and carbon dioxide are the breaths of a living planet, signals that could one day confirm that the silence of the universe is not absolute. As we look deeper into the indigo void, we realize that our own planet is just one among billions, a tiny island in a vast and beautiful sea of stars. The exoplanet frontier is the ultimate testament to our desire to find our place in the cosmos. It is a story of light and shadows, of distant suns and hidden worlds, echoing in the eternal silence of the navy blue sky. We are the children of the stars, looking for our siblings in the dark, and the journey has only just begun. In the vast and silent expanse of the navy blue cosmos, distances are measured in lifetimes and light years. When we look out from our small blue island, past the orbits of the gas giants, and beyond the frozen realm of the Kuiper Belt, the closest star system to our own is Alpha Centauri. It is a shimmering jewel in the southern sky, a beacon that has called to explorers and dreamers for centuries. But hidden within the glare of its two primary stars lies a third companion, a faint and reddish ember known as Proxima Centauri. This small and dim star holds a secret that has captivated the scientific world. Orbiting around this cool red dwarf, in the eternal silence of the deep space, is a world that might be a mirror image of our own. This is Proxima Centauri b, the closest known exoplanet to Earth. At a distance of only 4.2 light years, it is practically in our backyard in cosmic terms. Yet, this short distance is an immense abyss that current human technology cannot cross in 1,000 lifetimes. To send a probe, there would take tens of thousands of years of silent travel through the absolute cold of the interstellar void. So for now, we must rely on our telescopes and our imagination to unlock the secrets of this distant neighbor. Proxima b is a rocky world, slightly larger than Earth, sitting in the Goldilocks zone of its parent star. This means that the temperature on its surface could theoretically allow for liquid water to exist, creating oceans that reflect the deep red light of its alien sun. But this is where the similarities with Earth likely end. Because Proxima Centauri is a red dwarf, it is much cooler and dimmer than our sun. To receive enough warmth, the planet must orbit incredibly close to the star, completing an entire year in just 11 Earth days. This extreme proximity likely leads to a phenomenon known as tidal locking. Just as our moon always shows the same face to the Earth, Proxima b likely always shows the same face to its star. Imagine a world where the sun never sets on one side, a land of eternal day where the ground is baked by constant reddish heat. On the other side is a hemisphere of eternal night, a frozen wasteland shrouded in perpetual darkness where temperatures plunge far below anything recorded in Antarctica. Between these two extremes lies the twilight zone, a narrow ribbon of land running around the entire planet where the star is forever locked on the horizon, casting long shadows across a landscape bathed in a perpetual sunset. The sky of Proxima b would be a sight of alien beauty and terrifying power. The star would appear 3 times larger than our sun does in Earth's sky, glowing with a deep, moody orange-red light that would dye the landscape in shades of crimson and ochre. If the planet has an atmosphere, the clouds might be tinged with pink or violet, drifting lazily in the heavy air. But this red sun is not a gentle provider. Red dwarfs are notoriously violent and unstable stars. They frequently erupt with massive stellar flares, blasting their surroundings with intense bursts of ultraviolet and X-ray radiation. These flares could strip away the atmosphere of a nearby planet over millions of years, leaving behind a barren and irradiated rock. The secret of Proxima B lies in this delicate balance between the potential for life and the fury of its star. Is it a lush ocean world thriving under a red sky, or is it a dead and silent tomb, sterilized by the very light that should have given it life? In the navy blue silence of the void, Proxima B remains a beckoning mystery, a tantalizing glimpse of what lies just beyond our reach. It is a reminder that the universe is full of worlds that are both strange and wonderful, waiting patiently in the dark for us to find them. As our cosmic journey continues through the silent, navy blue depths of the Milky Way, we leave the neighborhood of our sun and venture hundreds of light years into the unknown, where the stars we see are but distant memories of a time long past. Our destination is the Cygnus constellation, a region of the sky that appears as a majestic swan flying through the starry river of our galaxy. Hidden within the countless stars of this constellation, about 500 light-years from Earth, lies a small, unassuming star known as Kepler. It is a red dwarf, much like Proxima Centauri, but it is slightly cooler and dimmer than our own sun, glowing with a soft, reddish-orange light that casts long, deep shadows across the emptiness of space. Orbiting this quiet star is a system of 5 known planets, worlds of rock and ice that have never felt the warmth of a yellow sun like ours. Among these distant siblings, one planet stands out as a beacon of hope in the dark. It is Kepler 186f, the first Earth-sized planet ever discovered in the habitable zone of another star. It is a world that has captured the imagination of scientists and dreamers alike, a tantalizing hint that somewhere in the vastness of the cosmos, another Earth might be waiting to be found. Kepler 186f is almost exactly the same size as Earth, a rocky sphere with enough gravity to hold onto a thick atmosphere and potentially support liquid oceans on its surface. It orbits its star at a distance that is perfectly balanced, receiving just enough heat to allow water to flow freely. A year on this planet lasts about 130 Earth days, meaning it is much closer to its star than we are to ours. But because its sun is so cool and dim, the light that reaches the surface of Kepler 186f would be very different from what we are used to. Imagine standing on the shore of an alien ocean as noon approaches. The sun in the sky would appear about 30% larger than our own, but it would not be a brilliant white orb. Instead, it would be a deep, moody orange ball, glowing with an intensity that is only a fraction of our sun's noonday brightness. The light would be soft and diffused, similar to the light on Earth just an hour before sunset. The sky, instead of a bright azure blue, might be a deep, dusty orange or a soft, muted purple, reflecting the reddish hues of the star. It would be a world of eternal twilight, a landscape bathed in perpetual sunset colors where the shadows are long and the air is filled with a quiet, ethereal glow. This dim, reddish light has profound implications for the potential life that might exist on this distant world. On Earth, plants use a green pigment called chlorophyll to absorb the high-energy blue and red light from our yellow sun. This is what gives our forests and jungles their vibrant green color. But on Kepler 186f, the available light is shifted toward the infrared part of the spectrum. If plant life has evolved on this planet, it would likely need to use a different kind of pigment to efficiently harvest the energy from its red sun. Scientists speculate that the forests of Kepler 186f might not be green at all. Instead, they could be a stunning array of deep reds, dark purples, and even black, as these colors would be more efficient at absorbing the faint, low-energy light of a red dwarf. Imagine a landscape covered in trees with leaves the color of dried blood or dark wine, a crimson jungle under an orange sky. The oceans might appear dark and moody, reflecting the somber tones of the heavens above. It would be a world of alien beauty, a testament to the incredible adaptability of life to thrive in the most unexpected environments. In the silence of the deep navy void, Kepler 186f is a silent canvas where the universe might have painted a masterpiece of evolution in shades of red and shadow, a world of secrets waiting in the eternal dusk. Further into the dark tapestry of the cosmos, about 40 light-years from Earth in the constellation Aquarius, lies one of the most extraordinary discoveries of modern astronomy. It is a system so compact and so rich with potential worlds that it feels like something out of science fiction. This is the TRAPPIST-1 system, a cosmic family of 7 Earth-sized planets orbiting a single, ultra-cool red dwarf star. The star itself is a tiny thing, barely larger than Jupiter and shining with a feeble brightness that is only a fraction of our sun's. Yet, its weak gravitational pull holds 7 rocky siblings in a tight, intricate dance that has captivated scientists around the world. The entire system is incredibly small, with all 7 planets orbiting closer to their star than Mercury does to our Sun. If you were to stand on the surface of one of these worlds, the other planets would not just be points of light in the night sky. They would appear as large, detailed orbs, sometimes looming as large as the full moon seen from Earth, their clouds and continents visible to the naked eye. It would be a sky filled with neighbors, a constant reminder that you are part of a larger cosmic family. The most tantalizing aspect of the TRAPPIST-1 system is that 3 of its 7 planets, labeled E, F, and G, orbit within the star's habitable zone. These are the 7 sisters of the deep, and they represent some of our best hopes for finding life beyond our solar system. TRAPPIST-1e is very similar in size and density to Earth, suggesting it could be a rocky world with a metallic core. It receives about the same amount of light from its star as Earth does from the Sun, making it a prime candidate for liquid water oceans. TRAPPIST-1f is slightly larger and might be a water-rich world, possibly covered in a global ocean with no landmasses to break the endless expanse of blue. TRAPPIST-1g is the outermost of the habitable planets, a cold world that might be covered in a thick layer of ice, perhaps hiding a subsurface ocean kept warm by geothermal vents deep below. Each of these worlds presents a unique set of possibilities, a different roll of the cosmic dice in the game of life. But the TRAPPIST-1 system is not a peaceful paradise. The proximity of the planets to their star and to each other creates a chaotic environment. The gravitational tug-of-war between the planets is intense, causing their orbits to resonate in a complex mathematical pattern. This resonance is what keeps the system stable, preventing the planets from crashing into each other over billions of years. However, this same gravitational interaction also causes extreme tidal forces on the planets. Just as the moon's gravity creates tides on Earth, the gravity of the other planets and the star would stretch and squeeze these worlds, generating immense internal heat. This could lead to massive volcanic activity on the surfaces of the inner planets, making them hellish landscapes of magma and ash. The outer planets might have geysers erupting through their icy shells, spraying water vapor into the thin atmosphere. The red sun, while dim, is also prone to violent outbursts of radiation that could strip away atmospheres and sterilize surfaces. Despite the challenges, the TRAPPIST-1 system remains a beacon of hope in the navy blue silence. Its discovery has shown us that Earth-sized planets are not rare cosmic accidents, but are likely common throughout the galaxy. It challenges us to rethink our definitions of habitability and to consider that life might thrive in environments vastly different from our own. As we look at this tight-knit family of worlds, we are looking at a mirror of possibility, a glimpse into the incredible diversity of planetary systems that exist in the dark. The Seven Sisters of the Deep are a reminder that we are not alone in the universe, and that the search for another Earth is just beginning. In the eternal twilight of the Red Dwarf, these worlds wait, silent witnesses to the long history of the stars, their secrets hidden in the deep indigo shadows of the cosmos. In the silent and majestic theater of the deep navy blue cosmos, the diversity of worlds is not limited to small rocky islands like our own. As we move past the interterrestrial realms and look toward the distant reaches of other star systems, we encounter the true heavyweights of the universe. These are the gas giants and the mysterious super-Earths, worlds where gravity is the absolute and undisputed master. In our own solar system, Jupiter stands as the king of planets, a massive ball of hydrogen and helium so large that 1,300 Earths could fit inside its swirling clouds. But as we peer into the indigo darkness of distant galaxies, we have discovered that Jupiter is only the beginning. We have found hot Jupiters, gas giants that orbit so close to their parent stars that their atmospheres are heated to thousands of degrees, causing them to glow with a haunting infrared light. These are worlds of fire and shadow, where the very air is made of vaporized rock, and where the winds howl at thousands of miles per hour across a landscape that has no solid ground. The environment within these gas giants is a descent into a beautiful and terrifying nightmare of physics. As you move deeper through the layers of swirling azure and violet clouds, the pressure increases to levels that are impossible to imagine. The gas does not just become denser, it undergoes a fundamental transformation. Deep within the heart of a giant planet, the hydrogen is crushed with such ferocity that it turns into a liquid metal, a shimmering ocean of metallic hydrogen that generates a magnetic field so powerful it could strip the electronics from a passing spacecraft in an instant. There is no surface to land on, no solid rock to stand upon. There is only a never-ending fall into a crushing abyss of heat and light. These giants are the architects of their systems, their massive gravity acting like a cosmic vacuum cleaner that sweeps up debris and protects the smaller rocky worlds from devastating impacts. They are the silent guardians of the void, looming in the dark like ancient gods of gravity. But perhaps even more mysterious are the worlds that exist between the size of Earth and the size of Neptune. These are the super-Earths, a category of planet that does not exist in our own solar system, but appears to be the most common type of world in the entire galaxy. A super-Earth is a massive rocky planet, sometimes 10 times the weight of our own home, where gravity is so intense that every movement would feel like a struggle against an invisible weight. If you were to stand on such a world, your own body would feel as heavy as lead, and your heart would labor to pump blood against the relentless pull of the ground. These worlds are often wrapped in thick, suffocating atmospheres of carbon dioxide or steam, trapping the heat of their sun in a permanent greenhouse effect. Some may be covered in global oceans thousands of miles deep, where the pressure at the bottom is so great that the water is compressed into exotic forms of ice that never melt, even at temperatures of hundreds of degrees. The mystery of why our own solar system lacks a super-Earth is one of the great unanswered questions of astronomy. Why did our sun produce small rocky worlds and massive gas giants, but nothing in between? As we look at these gravity-dominated giants in the navy blue silence, we realize that we are the exception rather than the rule. The universe is filled with worlds that are far more extreme and far more massive than anything we have ever known. These giants are monuments to the power of matter and the insatiable reach of gravity. They are worlds of crushed light and liquid metal, floating in the indigo dark as a reminder of the scale of the cosmos. Every gas giant and every super-Earth we discover is a new chapter in the story of planetary evolution, a silent witness to the infinite variety of the stars. In the eternal twilight of the deep, these giants remain as the heavy anchors of reality, their secrets hidden beneath layers of clouds and the crushing weight of their own existence. In the deep navy blue silence of the cosmos, where stars are scattered like grains of salt across an infinite velvet cloth, we encounter a class of world that defies our very understanding of stability and structure. These are the water worlds, the ocean planets that exist without a single acre of dry land to break the surface of their endless blue expanses. Imagine a world where the horizon is a perfect, unbroken circle of water in every direction, meeting the dark navy sky in a seam of perpetual mist and storm. On Earth, the oceans are merely a thin film of moisture coating a rocky sphere, a layer so shallow that if our planet were the size of an apple, the water would be thinner than the skin. But in the deep reaches of the galaxy, we have discovered planets where the water is not a layer, but a massive part of the planet's total mass. These are worlds where the ocean is hundreds, perhaps thousands of miles deep, a liquid realm so vast that the concept of a bottom loses all earthly meaning. In these indigo-hued environments, gravity and pressure create a reality that is both haunting and majestic. The atmosphere of a water world is a thick, heavy blanket of humidity and clouds. Because there is no land to slow down the movement of the air, the winds can reach incredible speeds, whipping the surface of the global ocean into waves that are hundreds of feet high. These waves travel forever across the globe, never crashing against a shore, never losing their energy to the resistance of a beach. Above these crashing waves, the sky is a permanent indigo shadow, filled with massive thunderstorms that illuminate the dark water with flashes of violet electricity. The rain here is constant and heavy, a never-ending cycle of evaporation and precipitation that fuels the global engine of the storm. As you descend beneath the surface, the light of the parent star begins to fade into a deep sapphire glow, then to an absolute navy blue, and finally to a crushing darkness that has reigned for billions of years. This is the true abyss, a place where the pressure is so immense that it begins to alter the very chemistry of the water itself. In the deep heart of these ocean planets, water does not behave the way it does on Earth. As you travel thousands of miles down, the weight of the water above becomes so great that the molecules are forced together into exotic states of matter. At these depths, even though the temperature may be hundreds of degrees Celsius, the water is compressed into a solid form known as Ice 7, or hot ice. This is a crystalline structure so dense that it would sink in a regular ocean, forming a massive shell that encases the rocky core of the planet. Between this layer of exotic ice and the liquid ocean above, there may be a region of supercritical fluid, a state where the distinction between liquid and gas disappears. This is the hidden world of the deep navy, a place of extreme physics where the building blocks of life might find a way to survive in the dark. Without a solid surface for nutrients to wash into the sea, the potential for life in these worlds depends on the hydrothermal vents that might exist at the very bottom of the liquid layer, spewing minerals and heat into the indigo darkness. The existence of water worlds challenges our perception of what a habitable world should look like. We often look for a second Earth with continents and shallow seas, but the universe seems to favor these fluid giants. They are the most common type of planet in certain parts of the galaxy, floating in the dark as silent monuments to the abundance of water in the cosmos. Each water world is a unique masterpiece of fluid dynamics and planetary evolution, a world that exists in a state of eternal flow. As we contemplate these landless oceans in the deep navy silence, we realize that our own world is a rare and precious exception. The universe is filled with oceans that have no shores and waves that never break. These worlds remain as the great sapphire mysteries of the void, their secrets hidden beneath miles of crushing water and the heavy silence of the indigo clouds. They are the cathedrals of the deep, echoing with the sound of a world that is forever in motion, forever silent, and forever blue. In the vast and silent cathedral of the night, not every world is born to dance around a star. There is a class of planets that are the true wanderers of the galaxy, the silent orphans cast out into the eternal cold. These are the rogue planets, worlds that have been ripped from their solar systems by the violent gravitational forces of their birth, or perhaps by a close encounter with a passing star. They are the exiles of the cosmos, traveling alone through the immense emptiness of the navy blue void, far from the warming light of any sun. We once thought that planets could only exist in stable orbits, bound to their parents by the unbreakable chains of gravity. But recent discoveries have shown that the galaxy is teeming with these free-floating worlds. Some estimates suggest there may be twice as many rogue planets in the Milky Way as there are stars, billions of silent sentinels drifting in the dark. A rogue planet is a world of profound and terrifying loneliness. Imagine standing on the surface of such a planet, where there is no sunrise and no sunset. The sky is not a vibrant blue, but a deep, unending black, filled with stars that never seem to move, locked in their positions against the eternal tapestry of the void. The temperature on the surface would be just a few degrees above absolute zero, cold enough to freeze the very air we breathe into solid ice. These are worlds of crystalline ammonia oceans and glaciers of frozen methane that flow like slow rivers of glass under a sky that has never known the warmth of a day. The silence here is absolute, broken only by the internal groans of the planet as it cools over billions of years. Yet, even in this frozen darkness, life might find a way. Although the surface is a frozen wasteland, the heart of a rogue planet can still be alive with heat. The decay of radioactive elements deep within its core can generate enough energy to keep the interior warm for eons. This internal heat could melt the ice deep underground, creating vast subsurface oceans of liquid water that are insulated from the freezing vacuum above by miles of rock and ice. In these hidden seas, shielded from the deadly radiation of space, life could thrive around hydrothermal vents, feeding on the chemical energy spewing from the planet's core. It would be a life that has never seen the light of a star, a biosphere that exists in eternal darkness, its creatures evolving in ways that are utterly alien to us. The discovery of rogue planets challenges our definition of what a home is. We have always believed that life needs the constant light of a sun, but these orphan worlds suggest that life might be possible in the most unexpected places. They are the silent ambassadors of the dark, reminders that the cosmos is larger and more complex than we can imagine. As we look out into the deep navy silence, we must consider that the galaxy is not just a collection of sun-drenched systems, but a vast ocean of lone wanderers. They are the ghosts of solar systems past, the remnants of violent cosmic events that have been set adrift to sail the endless night. Every rogue planet is a unique world, a silent traveler carrying its own secrets through the indigo shadows. They are the true nomads of the universe, finding their path in the absolute dark, and their journey has no beginning and no end. Far beyond the orbit of Neptune, far beyond the frozen dwarf worlds of the Kuiper Belt, and even beyond the point where the solar wind gives way to the interstellar medium, lies the true and final boundary of our solar system. We have reached the Oort cloud, a theoretical concept so vast and so distant that it challenges the very limits of human comprehension. Imagine a colossal sphere enveloping our entire planetary system, a cosmic cocoon made of trillions of icy objects orbiting in the deepest trenches of the navy blue void. This is not a flat disk like the rings of Saturn or the plane of the planets, but a massive, three-dimensional shell that surrounds us on all sides, extending almost a quarter of the way to the nearest star. The Sun, viewed from this staggering distance, is no longer the life-giving orb we know. It has been reduced to just the brightest star in a sky filled with an infinite number of unblinking points of light against a backdrop of eternal indigo silence. The gravitational hold of the Sun is so weak here that the objects in the Oort cloud move at a glacial pace, taking millions of years to complete a single lonely orbit around the distant center. The denizens of this frozen realm are the ancient leftovers from the violent birth of our solar system 4.6 billion years ago. They are the building blocks that never managed to form into planets, kicked out into the shivering darkness by the immense gravitational forces of young Jupiter and Saturn. These are the comets in deep freeze, mountains of dirty ice, frozen gases like methane, ammonia, and carbon monoxide mixed with primordial dust and rock. They float in the absolute cold, preserved perfectly in the vacuum of space like fossils waiting to be discovered. For eons, they drift in the dark, their surfaces scarred by micrometeoroid impacts and darkened by billions of years of exposure to faint cosmic radiation. They are the silent sleepers of the galaxy, existing in a state of suspended animation where time has almost no meaning. The distance between these objects is immense. You could fly a spaceship through the Oort cloud for 1,000 years and never come close enough to see one of these icy ghosts with the naked eye. It is a region of profound emptiness, a testament to the sheer scale of the space that separates the stars. Occasionally, the delicate gravitational balance of this icy shell is disturbed. A passing star, a giant molecular cloud drifting through the galaxy, or even the tidal forces of the Milky Way itself can nudge one of these sleeping comets out of its slow orbit. When this happens, the object begins a long and perilous fall toward the inner solar system. As it plunges closer to the Sun after millions of years in the dark, the increasing heat causes the frozen gases on its surface to sublimate, turning directly from solid ice into vapor. This process creates a magnificent glowing atmosphere around the nucleus, known as a coma, and a spectacular tail of gas and dust that can stretch for millions of miles across the navy blue sky. These are the long-period comets that have terrified and fascinated humanity throughout history, the sudden visitors from the deep that appear in our night sky like omens from the gods before vanishing back into the void, perhaps never to return. The Oort cloud is more than just a reservoir of comets. It is the ultimate boundary of our home. It is the final frontier before the true interstellar ocean begins. Our fastest spacecraft, like Voyager, will take another 300 years just to reach the inner edge of this cloud, and will spend the next 30,000 years silently navigating through its vast expanse before finally emerging on the other side. It is a reminder of how small our planetary neighborhood truly is in the grand scheme of the cosmos. We live in a small, warm bubble protected by a massive, frozen shield that guards us from the deeper, darker mysteries of the galaxy. The Oort cloud is the silent sentinel of the solar system, a graveyard of ancient ice that marks the end of the sun's domain and the beginning of the infinite, navy blue unknown. In the silent and majestic depths of the navy blue cosmos, far beyond the lonely boundaries of the Oort cloud and the reach of any single sun, we encounter the most beautiful and awe-inspiring structures in the entire universe. These are the nebulae, the vast and glowing clouds of gas and dust that serve as the cosmic nurseries where new stars are born. For millions of years, the interstellar medium drifts in the indigo darkness, a thin mist of hydrogen, helium, and microscopic grains of carbon and silicon. To the naked eye from a distance, these clouds appear as ghostly veils of light, delicate and fragile against the absolute blackness of the void. But as we move closer, we realize that these structures are of a scale that defies human imagination, stretching for hundreds of light years in every direction. They are the cathedrals of creation, where the raw materials of the universe are gathered by the invisible hands of gravity to begin the cycle of life once again. Each nebula is a unique masterpiece of light and shadow, reflecting the history of the stars that came before and the potential of those yet to be ignited. There are many types of these celestial clouds, each telling a different story of the cosmic process. We see the emission nebulae, glowing with a vibrant and haunting red light. This color is the signature of hydrogen gas being energized by the intense ultraviolet radiation from nearby young stars. The atoms are excited to such a degree that they release photons of light, turning the entire cloud into a massive neon sign in the deep navy sky. Then there are the reflection nebulae, which do not emit their own light but instead scatter the blue light of hot stars located within or near them. They appear as a deep sapphire mist, a cold and beautiful reflection of the stellar fire that illuminates the surrounding darkness. And perhaps most mysterious of all are the dark nebulae, clouds so dense and thick with cosmic dust that they completely block the light from the stars behind them. They appear as silhouetted voids, dark holes in the tapestry of the Milky Way, where the secrets of star birth are hidden from our prying eyes in the absolute indigo shadow. Inside these massive clouds, a magnificent and violent transformation is taking place. In regions where the gas is coldest and densest, gravity begins to pull the molecules together into tight pockets. These are the stellar nurseries, often referred to as pillars of creation. As the gas collapses under its own weight, it begins to spin and heat up, forming a protostar at the center. This is a star in the womb, a glowing core of energy that is not yet hot enough to trigger nuclear fusion. Around this growing heart, a flat disk of dust and gas begins to rotate, the same material that will one day form planets, moons, and perhaps the building blocks of life itself. We are witnessing the very beginning of a new solar system, a process that takes millions of years of patient accumulation in the silent void. The heat rises to millions of degrees until, in a single moment of cosmic triumph, the first sparks of nuclear fire ignite. A new star is born, and its first breath of light blasts away the surrounding cocoon of gas, revealing its brilliant face to the navy blue universe for the first time. The cycle of the nebulae is an eternal one, a constant dance between death and rebirth. The heavy elements forged in the hearts of ancient stars that died in supernova explosions are returned to these clouds, enriching them with the materials needed for future generations. Every atom in your body was once part of a nebula like the ones we see drifting in the deep indigo. We are the children of these cosmic clouds, the living proof of the universe's ability to turn cold gas and dust into complex and thinking beings. As we gaze upon the swirling patterns of the Orion Nebula or the majestic towers of the Eagle Nebula, we are looking at our own origin story. These structures are the silent witnesses to the passage of eons, remaining as the great architects of the galaxy. They are the source of all light and all life, floating in the eternal silence of the navy blue sky as a reminder that even in the coldest and darkest reaches of space, the fire of creation is never truly extinguished. The journey through the nebulae is a journey into the heart of the mystery, where the void becomes a cradle and the darkness gives birth to the light. As our journey takes us deeper into the magnificent expanse of the Eagle Nebula, located about 7,000 light-years from Earth in the constellation Serpents, we come face to face with one of the most iconic and breathtaking sights ever captured by human technology. These are the Pillars of Creation, three colossal towers of cold gas and dark interstellar dust standing vigil in the deep navy blue cosmos like ancient sentinels of the void. These structures are so vast that the tallest pillar on the left stretches for a staggering 4 light-years from base to tip. To put that scale into perspective, our entire solar system, from the Sun out to the distant Oort cloud, could easily fit inside one of these gentle curves of dust. They appear solid and immutable, like geological formations carved from stone and rock, standing firm against the currents of space. But this solidity is an illusion. They are composed of tenuous clouds of molecular hydrogen, helium, and microscopic dust grains that are only slightly denser than the surrounding vacuum. They exist in a delicate balance, sculpted by forces of unimaginable power that are both creating and destroying them simultaneously. The name Pillars of Creation is not just poetic metaphor. It is a literal description of what is happening inside these dark and mysterious towers. Hidden deep within the densest knots of these dusty columns, shielded from the harsh radiation of the outside universe by thick layers of gas, new stars are being born right now. Gravity is slowly pulling the clumps of matter together, compressing them into tighter and hotter spheres until the nuclear fires ignite. If we could look inside these opaque cocoons with infrared eyes that pierce through the dust, we would see dozens of faint reddish glows. These are protostars, infant suns that are just beginning their long lives. At the very tips of the pillars, we can see small, finger-like protrusions sticking out into the glowing gas around them. Astronomers call these evaporating gaseous globules, or eggs for short. Each one of these tiny knobs is larger than our solar system and contains a newborn star struggling to emerge from its birth cloud. We are witnessing the moment of Genesis, the very process that created our own sun and Earth 4.5 billion years ago, playing out on a grand cosmic stage against a backdrop of eternal indigo. However, there is a profound irony at the heart of this masterpiece. The very process of creation is also leading to the pillars' ultimate destruction. To the upper right of these towers sits a cluster of massive, hot, young stars that were born from the same nebula only a few million years earlier. These brilliant blue-white giants are blasting the pillars with torrents of scorching ultraviolet radiation and powerful stellar winds. This intense bombardment is slowly eroding the tops of the columns, boiling away the gas into the vacuum of space, just as sunlight evaporates a morning mist. The glowing halos of blue and green light that outline the edges of the pillars are the signature of this violent evaporation. The gas is being heated and ionized, stripping electrons from atoms and causing them to shine. The pillars of creation are ephemeral structures in the grand scheme of cosmic time. Scientists estimate that they are being destroyed at such a rate that they will likely have completely evaporated within the next 3 million years. In fact, some theories suggest that a nearby supernova explosion may have already toppled them. And because light takes 7,000 years to reach us, we are only seeing a ghostly afterimage of structures that no longer exist. This makes the view even more poignant. It is a snapshot of fleeting beauty in a universe defined by constant change. Deep within the shrouded depths of the dark nebulae, hidden from the prying eyes of optical telescopes by trillions of miles of opaque dust, a primordial struggle is taking place. It is a war of forces on a cosmic scale where gravity, the patient and relentless sculptor of the universe, is slowly winning against the expansive pressure of the gas itself. We often think of star birth as a gentle process, a slow gathering of light in the dark. But the reality is a chaotic and violent cataclysm that plays out over millions of years in the deep navy silence. The process begins in the coldest and densest regions of a molecular cloud, where the temperature is only a few degrees above absolute zero. Here, a clump of gas slightly denser than its surroundings begins to collapse under its own weight. As it shrinks, it begins to spin faster and faster, obeying the laws of angular momentum. This spinning causes the cloud to flatten into a vast pancake-shaped disk of dust and gas, with a dense, hot core forming at the center. This is the protostar, a monstrous ball of glowing hydrogen often hundreds of times larger than our sun, yet still not hot enough to ignite the nuclear furnace that defines a true star. The environment around a developing protostar is a maelstrom of energy and matter. As material from the surrounding disk rains down onto the surface of the growing giant, it travels at supersonic speeds, creating massive shock waves that heat the gas to thousands of degrees. The magnetic fields of the protostar, twisted and amplified by its rapid rotation, become powerful particle accelerators. They launch colossal jets of superheated plasma from the star's poles, blasting outward into the surrounding nebula at nearly the speed of light. These jets can stretch for light years, punching holes through the dark cloud and creating brilliant, glowing shock fronts known as Herbig-Haro objects. These are the first fiery cries of a newborn star, announcing its imminent arrival to the galaxy. The protostar continues to grow, greedily consuming its parent cloud, its core temperature climbing higher and higher with every passing millennia. It is a pressure cooker waiting to explode, a ticking time bomb of potential energy hidden in the indigo dark. Then, after millions of years of dark gestation, the critical threshold is crossed. Deep in the absolute center of the protostar, the crushing weight of the overlying layers forces the hydrogen atoms together with such violence that they fuse into helium. In a fraction of a second, a nuclear furnace is ignited. A blast wave of pure energy, light, heat, and intense radiation erupts from the core and races outward to the surface. The star turns on with a blinding flash that illuminates the entire nebula from within. This sudden outpouring of energy creates a powerful stellar wind, a hurricane of charged particles that slams into the remaining shroud of gas and dust surrounding the star. The violent birth process is the very thing that clears the delivery room. The cocoon is torn apart, pushed outward in a massive, expanding bubble of glowing gas. The new star, now a stable main sequence object like our sun, shines free in the navy blue cosmos for the first time. The violence of its creation is over, replaced by a steady and brilliant burn that will last for billions of years. We are left looking at a new point of light in the night sky, unaware of the chaotic struggle that was required to bring it into existence. In the silent and infinite expanse of the deep navy blue void, stars are rarely born in total isolation. Just as humans find strength in community, the stars of the Milky Way often begin their long journeys as part of a collective, a celestial family bound together by the invisible yet unbreakable threads of gravity. These are the star clusters, magnificent gatherings of suns that illuminate the indigo darkness like spilled jewels across a velvet tapestry. When a massive molecular cloud finally collapses and gives birth to a new generation of light, it does not produce a single star, but hundreds or even thousands of siblings all at once. These young stars are born from the same cradle of gas and dust, sharing the same chemical DNA and the same cosmic heritage. They are the open clusters, the vibrant and energetic nurseries of the galaxy, where the youngest suns begin their lives in a chaotic yet beautiful dance of light and motion. We see them as tight groupings of brilliant blue and white stars, their light cutting through the surrounding navy mists of their birth clouds with a fierce and youthful intensity. The most famous of these open clusters is the Pleiades, often called the Seven Sisters, a shimmering cluster of stars that has guided travelers and inspired poets for thousands of years. To look at an open cluster is to witness the early days of a stellar family. The stars are close together, their gravitational pulls keeping them in a loose but stable arrangement as they drift through the spiral arms of the galaxy. But the life of an open cluster is relatively short in the grand scheme of cosmic time. As the cluster travels, the gravitational tugs from passing gas clouds and other stars begin to slowly pull the siblings apart. One by one, the stars drift away from their birthplace, setting out on their own independent journeys through the navy blue unknown. Our own sun was likely born in such a cluster 4.5 billion years ago, surrounded by hundreds of sisters and brothers that have long since scattered across the far reaches of the Milky Way. We are the descendants of a lost family, now sailing alone in the dark, yet connected to the stars by the shared history of our birth. However, there is another type of stellar family that exists on a far grander and more ancient scale. These are the globular clusters, the great cities of stars that orbit the center of the galaxy like silent sentinels of the deep. While an open cluster may contain a few hundred stars, a globular cluster is a massive sphere of light containing hundreds of thousands, or even millions, of suns packed tightly together into a dense and shimmering ball. These are the oldest objects in the universe, relics from the dawn of time that have survived for over 12 billion years. In the deep indigo silence of a globular cluster, the stars are so close together that from the center of the cluster, the night sky would never be truly dark. It would be filled with 1,000 suns as bright as the full moon, creating a landscape of eternal light and silver shadows. These ancient families are the survivors of the cosmic wars, their gravity so strong that they have stayed together since the very beginning of the galaxy's formation. The dynamics within a globular cluster are a complex and violent ballet. Because the stars are so crowded, they are constantly interacting with one another, their paths being altered by the gravity of their neighbors. Occasionally, two stars may pass so close to each other that they collide or merge, creating a massive and rejuvenated star known as a blue straggler. This is a place where time seems to slow down, where the history of the universe is written in the light of 1,000,000 ancient suns. These clusters are the anchors of the galaxy, floating in the navy blue void as reminders of the sheer scale and longevity of the stars. As we look at these brilliant spheres of light, we realize that the universe is a place of both fleeting youth and eternal age. The star clusters are the witnesses to the passage of eons, the silent families that define the structure and the beauty of the night sky. They are the gathering places of the light, glowing in the eternal darkness as a testament to the power of gravity to bring order to the chaos of the deep. As we pull back from the intricate dance of star clusters and the violent birth of new suns, we finally see the grand stage upon which all these dramas have played out for billions of years. We are looking at the Milky Way, our home galaxy, a magnificent island of light floating in the vast and endless navy blue ocean of the cosmos. It is a structure of overwhelming scale and beauty, a barred spiral galaxy containing anywhere between 100 billion and 400 billion stars, each one a potential sun to a system of worlds. Imagine a flat disk of stars, gas, and dust stretching across 100,000 light-years of space, a distance so immense that light itself takes 1,000 centuries to travel from one edge to the other. This disk is not static, but alive with motion, rotating majestically around its center like a colossal cosmic pinwheel. Our own sun, a relatively ordinary yellow star, is just one tiny speck located in the suburbs of this great city, tucked away in the Orion Arm about 26,000 light-years from the galactic core. We are travelers on a grand journey, orbiting the center of the galaxy once every 230 million years. The structure of the Milky Way is a masterpiece of gravitational architecture. At the very center lies the galactic bulge, a dense and brilliant sphere of ancient red and orange stars that have been burning for over 10 billion years. This is the oldest part of the galaxy, a crowded and chaotic region where stars are packed together 10,000 times more densely than in our own neighborhood. Yet, hidden in the absolute heart of this blazing light is a monstrous secret. A supermassive black hole known as Sagittarius A sits at the dead center of the Milky Way, a gravitational tyrant 4 million times heavier than our sun that dictates the motion of everything around it. Radiating outward from this central bulge are the majestic spiral arms, the sweeping lanes of stars, gas, and dust that give our galaxy its iconic shape. These arms are not rigid structures, but dynamic density waves that travel through the galactic disk, compressing the gas clouds as they pass and triggering new waves of star formation. They are the engines of creation, dotted with brilliant blue star clusters and glowing pink nebulae, where the next generation of suns is being born in the deep indigo silence. The entire galaxy is encased in a vast halo of hot gas and old stars, extending far beyond the visible disk into the deep navy void. Yet, what we can see with our eyes is only a small fraction of the true Milky Way. The vast majority of the galaxy's mass is made up of something we cannot see or touch, a mysterious and invisible substance known as dark matter. This dark matter forms a massive, spherical halo that envelops the entire galaxy, acting as the gravitational glue that holds the stars and gas together. Without it, the Milky Way would fly apart, its stars scattering into the intergalactic void like dust in the wind. We live in a galaxy that is mostly shadow, a structure where the light of 100 billion suns is just the frosting on a cake made of invisible darkness. As we look out at this grand spiral home, we realize that we are part of a living, breathing ecosystem of stars. The Milky Way is not just a place, it is a process, a continuous cycle of birth, death, and rebirth that has been unfolding for over 13 billion years in the eternal silence of the deep navy sky. As we leave the quiet suburbs of the Orion Arm and travel deeper into the glowing heart of our spiral home, the stars begin to crowd together with an intensity that is both beautiful and terrifying. We are entering the galactic center, the luminous and chaotic downtown of the Milky Way. In this region, the indigo silence of space is replaced by a dense and brilliant fog of ancient light. Here, the distances between stars are not measured in light years, but in light weeks or even light days. If our Earth were located in the heart of this stellar metropolis, the night sky would never be truly dark. Instead, it would be filled with 1,000 suns as bright as Sirius, casting sharp shadows across the landscape and turning the night into a perpetual twilight of silver and gold. This is a place of extreme physics and ultimate power, a region where the laws of the universe are pushed to their absolute limits. The airless void is thick with intense radiation, powerful magnetic fields, and swirling clouds of superheated gas that glow in the deep navy blue of the electromagnetic spectrum. At the very center of this brilliant sphere of stars lies a mystery that was hidden from our eyes for billions of years by thick curtains of interstellar dust. It is a place of absolute shadow, a gravitational anchor around which the entire galaxy rotates. This is Sagittarius A, the supermassive black hole that resides at the dead center of the Milky Way. It is a monster of staggering proportions, containing the mass of 4 million suns compressed into a point of zero volume. While the black hole itself is invisible, We can see its presence by the effect it has on the stars around it. These S-stars are caught in a violent gravitational dance, orbiting the invisible center at millions of miles per hour. They are the elite performers in a cosmic ballet, their paths dictated by the insatiable hunger of a tyrant that allows nothing, not even light, to escape its grasp once the event horizon is crossed. The space around the black hole is a maelstrom of activity, as gas and dust are drawn toward the abyss, forming an accretion disk that glows with a fierce and haunting light as it is crushed by gravity. The environment surrounding Sagittarius A is a masterpiece of complex structures. We see massive filaments of magnetic gas stretching for light years through the indigo void, like the glowing strings of a cosmic instrument. These filaments are the signatures of a magnetic field, so powerful it can channel the flow of matter across the galaxy. We see massive clusters of young, hot stars that have managed to form in this violent environment, defying the intense radiation and the gravitational tides that threaten to tear them apart. This is the true heartbeat of the Milky Way, a place of constant motion and eternal light. It is the anchor that gives our galaxy its structure and its identity. Without the silent power of the central black hole, the billions of stars in the spiral arms would have no center to hold them, and the majestic spiral would dissolve into the intergalactic dark. As we contemplate the galactic center in the deep navy silence, we feel a sense of profound scale and mystery. We are looking at the engine room of our home, a place where matter and energy are processed in the most extreme ways possible. The central black hole is not just a consumer of worlds, but a master of order, a silent guardian that keeps the cosmic dance in motion. It is a reminder that even in the brightest heart of the galaxy, there is a core of darkness that defines the light. Every star in the Milky Way, including our own sun, is bound to this invisible center by an unbreakable chain of gravity. We are all part of this grand rotation, a trillion-mile journey that has been unfolding for 13 billion years. The galactic center remains as the ultimate enigma of the deep, a place of brilliant suns and absolute shadows floating in the eternal silence of the navy blue sky. As we leave the brilliant spirals of the Milky Way behind and venture into the true intergalactic ocean, we enter a realm that challenges the very notion of existence. This is the space between the islands of light, the vast and terrifying expanses known as the Great Voids. In the deep navy blue silence of the cosmos, galaxies are not scattered randomly, but are gathered into long, gossamer filaments that form a cosmic web. But between these threads of light lie regions of absolute nothingness, pockets of the universe so empty that they contain almost no matter, no stars, and no light. These are the voids, the great cathedrals of shadow that make up the vast majority of the volume of the universe. To travel through a void is to experience the ultimate loneliness. Imagine a region of space millions of light years across where there is not a single sun to warm the dark, not a single planet to break the indigo horizon, and not a single photon of light that hasn't traveled for eons to reach you. It is a vacuum so perfect that it feels like a physical weight, a crushing silence that echoes the absolute beginning of time. The most famous of these empty realms is the Boötes void, a colossal sphere of nothingness nearly 330 million light-years in diameter. It is often called the Great Nothing, a place so barren that if the Milky Way were located in its center, we would not have discovered that other galaxies existed until the 1960s. To an observer inside the Boötes void, the night sky would be a solid wall of black, with only the faintest, most distant points of light visible through the most powerful telescopes. There are no nearby neighbors here, no cosmic families, only the terrifying scale of an empty stage. These voids are not merely empty space. They are the result of the expansion of the universe itself. As the cosmic web was pulled together by gravity over billions of years, the matter was drawn out of these regions and into the filaments and clusters, leaving behind these massive bubbles of indigo silence. They are the negative spaces of creation, the shadows cast by the light of a trillion suns. Yet, even in the heart of the great voids, the universe is not entirely dead. Astronomers have discovered a few lonely galaxies drifting within these empty regions, isolated orphans that exist in a state of profound solitude. These galaxies are often shaped differently than those in crowded clusters, appearing more pristine and undisturbed by the violent gravitational interactions of their neighbors. They are the hermits of the cosmos, silent witnesses to the scale of the nothingness that surrounds them. In the navy blue void, these galaxies represent the absolute limit of light's reach. As we contemplate these vast stretches of emptiness, we realize that the universe is mostly made of nothing. The stars, the planets, and the galaxies are just tiny flecks of foam on a dark and infinite ocean. The voids are the true face of the cosmos, a reminder that our existence is a rare and fragile miracle in a universe defined by the heavy silence of the dark. The study of these voids is essential to our understanding of the origin and the fate of the universe. They hold the secrets of dark energy, the mysterious force that is pushing the galaxies apart and causing the voids to grow even larger over time. As the eons pass, the threads of the cosmic web will stretch thinner and thinner, and the great voids will slowly consume the light until only islands of darkness remain. We are living in a golden age of light, a brief moment in cosmic history before the shadows claim the throne. As we sail through the deep indigo shadows of intergalactic space, we feel the breath of the infinite on our faces. The great voids are the ultimate frontier, the place where the silence is absolute and the darkness is eternal. They are the silent architects of the cosmic structure, the hollow spaces that give the universe its shape and its mystery. In the eternal silence of the navy blue sky, the voids remain as the final testament to the scale of the unknown, a beautiful and tragic echo of the vastness that lies between the stars. We have traveled across the billions of years and the trillions of miles, from the violent birth of the first stars to the silent drift of the last rogue planets. We have witnessed the majesty of the nebulae and the terrifying power of the supermassive black holes. But now, our journey reaches its ultimate and inevitable conclusion. We are looking at the final chapter of the cosmic story, the end of time itself. This is the era of the heat death, the state toward which the universe has been moving since the very first moment of the Big Bang. In the deep navy blue silence of the far future, the expansion of space has continued for so long that the galaxies have been pushed far beyond each other's horizons. The cosmic web has frayed and dissolved, leaving every group of stars as a lonely island in an infinite and growing ocean of darkness. The light of the universe is slowly but surely fading away, like the embers of a dying fire in a vast and frozen hall. The first stage of this long goodbye is the end of the age of stars. One by one, the great cosmic nurseries, the nebulae, run out of the raw hydrogen gas needed to ignite new suns. The brilliant blue giants are the first to go, exploding in spectacular supernovas that leave behind only cold remnants. Then, the yellow stars like our own sun swell into red giants before collapsing into white dwarfs, glowing with a faint and fading heat. Finally, only the red dwarfs remain, the small and patient survivors of the galaxy. But even their long lives must eventually come to an end. After trillions of years, the last red dwarf will flicker out, and the lights of the universe will be extinguished forever. The galaxies will become graveyards of cold cinders, black dwarfs, neutron stars, and black holes, floating in a void that is now perfectly dark and unimaginably cold. The indigo shadows will become absolute, and the era of light will be nothing more than a brief and forgotten memory in the infinite timeline of the deep. As the eons continue to pass, even the solid remnants of the stars will begin to dissolve. Through a process called proton decay, the very atoms that make up the planets and the cold suns will slowly break apart, turning matter into a thin mist of subatomic particles. The only structures left in the universe will be the black holes, the silent kings of the darkness. For unimaginable stretches of time, these monsters will be the only things that exist, drifting in the navy blue void and slowly consuming whatever remains of the light. But even the black holes are not immortal. Through the slow leak of Hawking radiation, they will begin to lose mass, evaporating atom by atom into the void. The smaller black holes will vanish first, ending their lives in brilliant flashes of gamma rays. The supermassive giants at the centers of galaxies will last for 10 to the power of 100 years, a number of years so large it cannot be written or understood. But eventually, even they will evaporate into nothingness, leaving behind a universe that is truly and completely empty. What remains is the state of maximum entropy. The universe is now a vast, uniform sea of low-energy particles, where the temperature is barely a fraction of a degree above absolute zero. There is no more energy to be exchanged, no more work to be done, and no more change to occur. Time still exists, but it has lost all meaning because nothing ever happens. The silence is total, the darkness is absolute, and the navy blue void is now the only thing that remains. We have reached the end of the journey. The grand experiment of the universe has concluded, and the light has returned to the silence from which it first emerged. As we contemplate this final stillness, we realize that our own existence was a beautiful and fragile miracle, a brief moment of light and consciousness in an eternal sea of shadow. The story of the stars is over, but the memory of our journey remains as a silent song in the deep indigo dark. We were here, we saw the light, and for a fleeting moment, we were the universe witnessing itself.